Greetings, Artie from Artifact Electronics here. In this episode, we'll be having a look at RFID tags and how they are used in video games. The RFID tag, and I will give closer explanations of what they are, but briefly, they're like a secured memory card, not unlike this SD card over here, except that they're contactless, which means you don't have to make electrical contact to interact with them. They're flat, they're basically flex PCBs, 2.5 centimeters in diameter, and since they're self-sticking, they can be applied to pretty much any surface that you desire. And all you need is to bring them into the proximity of an RFID reader in order to read their contents. RFID tags started out being used for inventory control and also theft control. Because they're essentially stickers, you can put them on any surface you want. They cost a few cents each depending on the quantities you acquire. And usually in stores that utilize these, there are reader coils installed near the exit and entrance doors. And when you pass through these doors, the readers will attempt to read these tags. And not only does it provide inventory control, if you just bought 2 doodads, the back end will immediately be notified that 2 doodads just left the store. But some are also used as theft control in that there's a bit on there that originally is set, meaning this thing hasn't been bought, and when it runs near the cash register, the bit gets reset saying that yes, it has been paid for. And if that bit is reset, then the exit doors on the store will remain quiet. But if they start yelling at you, that means that they just detected an RFID tag without the paid-for bit reset or set, whatever they may use, and that's how they are used for theft protection also. Now, the most common place you've probably used these at, not necessarily seen them in this form, but used them, are key cards used to enter secure locations, which most businesses nowadays utilize these. You have a small card reader next to the access doors, and if you bring your card close to those readers, the electromagnetic lock in the door will briefly disengage, allowing you entry into the premises. Now, not only does it allow you entry to the premises, but it will also transmit an ID telling the back end again whose ID just opened that door. Now, that doesn't provide you with a lot of security because cards can easily be stolen, exchanged, or whatever, but at least you can hold somebody responsible if your place was robbed, and you can at least pinpoint the person whose card was used at 3 a.m. in the morning to access the building. So with that said, now we can go on and have a look at, it was bound to happen, but how these can benefit video games. Here's a good example of the peripheral used with the Disney Infinity game, and which utilized RFID tags. What this is the RFID reader. RFID stands for Radio Frequency Identification, by the way, if I haven't mentioned that before. And the way it works, if we take this fellow, in his base, there is an RFID tag like the one we just saw. And when you put him on the reader will go ahead and read all the identifying information of this character. And now they are read-write, so you can read them, you can write stuff to them, you can date stamp them to know when was the last time you used it. And so what you see here, these toys, here's one in the original packaging and here's others out of the packaging, is that the toys are basically the RFID tag carriers. and they take a different form depending on what toy you have, but the way this reader works is you can actually stack several tags on top of each other. So if we want Donald to be here and we happen to have a tag that gives him superpowers or whatever, we place the tag underneath him like this, and the game will know that there's a Donald on the second reader slot, and he is also modified to have super strength or whatever. And there are also hexagonal tags or environmental tags which are used to not affect the character that they're under, but rather the game in itself, such as bringing in new textures, to changing the weather, changing the music, and all of that. So that's how a game would interact, or how those tags are used in a game. And other games that utilize this, Activision Skylanders, Nintendo's Amibos, and also Lego Dimension, used pretty much the same approach to integrating RFIDs for game piece identification. Let's have a look at some of the methods of how to detect a game piece. I'm going to use a chess computer as an example because that's an ideal candidate. There are several consumer playing pieces in there, and if there was a good way of detecting where a piece was and what it was, to aid the computer in playing and figuring out what's where on the chessboard. So the chess computer, you've seen them, they have the chessboard with usually some sort of a sensor under each square, and then of course the piece itself, which has embedded some sort of a stimulus or source for the data to be transmitted or to excite the sensors that are built into the chessboard. And the very first one, and probably the cheapest one, is utilizing a reed switch. So there is a reed switch under each square of the chessboard, and the chess pieces contain magnets, identical magnets. And the way a reed switch works, it is a normally open switch, and once you bring a magnet into proximity, the reed switch closes. That's why all this can provide is a make or break signal. And all you really know is whether the current square that you're scanning is occupied by a piece or not. You don't know which piece. So using that, you're kind of dependent on the player setting up the play field correctly in the beginning, and when moving pieces, being very careful about how to move them so as not to knock other pieces over. And it's a dicey way, it's kind of a dicey way to do player piece detection, but it was one of the more common ones used in early chess computers because it was the cheapest way to do it. And as far as the job of making itself known, of a piece making itself known on a square, was done pretty reliably. So the next way to do it was to utilize a Hall effect sensor, and the way a Hall effect sensor works is it puts out a voltage, an analog voltage that is proportional to the magnetic field applied to it. So again, all the playfield pieces had a magnet in them, and every square had a Hall effect sensor underneath it, and you had to scan all 64 squares and read the analog voltage it had to figure out which piece was on there. And I mean, the way you did piece identification was you put different strength magnets into the different pieces. So in a chess set, per color there are 6 different pieces for a total of 12 different pieces. So you just had to have 12 different strength magnets. I mean, the reason I'm saying that is obviously all the pawns weren't distinguished between. They all had the same magnet in it. I mean, this pawns of one color. Pawns of another color obviously had the same magnet, but of a different strength than the one that was used in the previous ones. To be able, you could tell that it was a pawn, and you could tell the color too. And theoretically, that worked really well. But because the Hall effect sensor is very sensitive to the placement of the magnetic field, if something wasn't placed exactly square in the, on a board square, centered on a board square, or other pieces overlapped or whatever, it could cause false readings, and it was also expensive. But it was also used in commercial chess computers. Now, of course, after what I've told you about RFID readers, that technically is probably the best way to do it, because every chess piece would have an RFID tag in it that clearly identifies it, its color and its function. Now, in the board, when you first look at it, you would need an RFID reader under every square in order to find out what piece is sitting on that square. But that is just not feasible to do, because the readers, compared to the tags, which are a few cents, the readers get much more expensive. And it doesn't make a whole sense to have a reader under every square, because it'll make the chess computer cost several $1,000s. However, one way to overcome that, and that is the same approach that was used in Disney Infinity, is to have a single reader, but have it scan, but basically have an antenna under each square, and selectively connect that antenna to the single reader that you have in the game. It, of course, knows, in effect multiplexing the reader to all 64 squares and just reading them in a round-robin fashion as time goes on. And you can read, it would probably take to reliably read them, about a second to read the whole board, maybe a little longer. But it would, no matter what you did with the pieces, if you put them on crooked, if you tried to cheat, if you just tried to do impossible thing, it would even detect if you had multiple pieces sitting on the same square. But again, the cost of doing this, I don't know if that's really economically feasible, even with multiplexing this piece. But it would provide you with a very accurate way of detecting playfield pieces on the chessboard. Now, of course, another method that has been tried that I haven't drawn here, and that is to use image recognition to basically have an overhead shot of the chessboard and image recognize the image that the camera generates on an ongoing basis, and thus figuring out where the pieces are. And quite a bit of research has gone into that too. I don't know the exact state of it at this point, but that is yet another way to do playfield piece recognition. Let's have a look at what the reader looks like on the inside. I've conveniently cracked one open, and you can see there's a main control board, and that contains all sorts of good stuff. But relevant to RFID, it contains the RFID reader itself over here, and there's only a single one, because each of these antennas are multiplexed and read in a sequential fashion. So when you put your tags on here, that it continuously reads the antennas and maintains a tag list, which is transmitted to the game code, so that the game at all times, or more accurately at most times, has an accurate representation of what tags are placed at that instant in time on the reader. And the tag list, of course, will tell you what kind of a tag it is, and it will also tell you which slot it found said tag on, so you can make some game decisions based on that information. This, of course, also lets you write back to the tag, so you can maintain things like levels that a character has achieved, or the last timestamp it, so you know when the last time it was played. And that's pretty much the reader side. If you look at these a little more closely, that's probably not very visible, but you can see that it has a spiral antenna around the perimeter here. which is fed straight into the multiplexer through these connectors here. It also has an RGB LED in the middle, but that has nothing to do with RFID functionality. It is simply used to prompt the player to do certain things. The other component we need, of course, is the RFID tag itself, embedded inside the toys or the coins that you place here. And if we have another look at this, if I can get a better shot, yes, it's not too reflective, but again we can see the circular antenna or the spiral antenna here, and which is directly connected to the processor, which does all the tag functionality. But essentially the way this works, it works through induction, because you have a coreless transformer where, say, the primary is on the slot here, and the secondary is on the tag itself. And it uses that to basically harvest the energy, power itself up. Well, the energy gets harvested, powers up the chip, and then the chip starts communicating at 14.58, 15. Let me see, what was it? Using, actually at 13.56 megahertz is where the digital data is superimposed onto the base AC that comes out of here, and that is used for bidirectional communications. Now, at this point you may wonder how many days and months I spent on reverse engineering this in order to be able to present this to you, and the answer is I've spent about 0 on reverse engineering this. Let's just say that I was closely involved in the design of this hardware. A bit more information on the tags themselves. These are called MyFair tags. They're made by NXP, and they operate at a communications frequency of 13.56 megahertz. They contain a read-only 7-byte UID, which is very similar to a MAC address on your network adapter. These particular tags have a total of 320 bytes of memory, and they do utilize a hardware key for you to be able to just read the raw data. Unfortunately, that breaking that hardware key turned out not to be too complicated, and shortly after Disney Infinity hit the market, there were utilities available online that would let you read the raw data. It didn't do people a whole lot of good because the data is deeply encrypted in software on top of the hardware encryption, but it was kind of unfortunate to find out that a supposedly secure tag really wasn't that secure after all. I'm sure that the hardware security on these tags has been updated, because I don't know what the max of these tags is, but at the time when Infinity was designed, I think the max tag capacity on these MyFair tags was 4K or 8K, and but I'm sure we've hit megabytes by now. So now comes time to see this thing in real action, and I could have just cheaped out and plugged this into an Xbox or a PlayStation and showed you something that's probably been done hundreds of times on YouTube. So of course only the best for the audience of Artifact Electronics, and I'm going to use this to demonstrate it. What this is it's a genuine Disney Infinity store display kiosk. Let me turn that on for you. And obviously this wasn't a commercially available product that you could just go out and buy, but rather these were given to stores, and when stores were done with it, and since Infinity is no longer a live product, probably got dumped in the hundreds. And I really wanted one, but I was too late. I could never lay my hands on one till one day in the local ads I spotted one. believe it or not. I went out there and the seller claimed to be in demolition, and they demolished a big store, and there happened to be one of these in there, and he just brought it home and his kid played with it, and finally his kid figured out that this thing, you can't really play the game on here, so this is useless, so let's just dump it. And I paid the grand sum of $35 for this, but this is what we're going to use to have a look at how everything works on here, and also have a brief look at making the energy harvesting visible. So when you went to a store, one of these was hanging on the main display rack, and it was surrounded by pegboards which had the toys on them. And if you had any doubts about buying any toys, you just pick up a toy like this and placed it on the reader. So it would read that, know that it's Mike, and play you a video of what Mike's capabilities were. Now, they didn't have videos for everyone, for every single item in particular. Some of them were grouped together. For instance, if you put coins on there, it played a generic coin video and stuff like that. But as you can see, that's just the way it works. Obviously, it is contactless because there's several layers of plastic between the reader, antennas, and the RFID tags. But that's what it was. So it would play the video for you, and when done with the video, it would revert back to the main loop. And just to demonstrate, if you put a coin on there, it would detect that a coin was placed there and play the generic coin video for you, or I guess they were officially called power discs. And that's pretty much what this thing does. It's a rare piece of video game history. I'm really glad I could find this thing. It was in pretty good working shape. I had to tweak it a little bit. Just for the curious, it's basically an Android tablet that with USB ports that's directly connected to the reader, and has custom software running on it that just plays back videos, plays the background loop, and then when it reads a character or a coin, it builds a file name based on the unique ID of that RFID tag, and basically searches to see if it has a video matching that name it just built, and if it does, it plays that video for you. So to demonstrate the energy harvesting, I've taken one of the antennas out of a reader, and what I've done, hopefully you can see that here, is all I've done is taken the antenna terminals and fed them directly to the green part of the RGB LED on here. There's nothing else here. There are, look, no false bottoms, no nothing. There are no capacitors, no extra regulation or rectification or anything like that. But here's what happens when I put this on the reader. Now, don't be distracted by the blinking of the lights there. As I said before, they have nothing to do with the RFID functionality, and it's simply the game, or I guess the demo, telling you, hey, put something on me so I can play a video for you. Also, that line going straight through it is a reflection of the LED frame around the monitor, and anything short of breaking this thing, I can't get rid of that line, so just ignore it. But here's what it looks like when I place it on there. So why isn't this on permanently? And that's because, again, it's being scanned. It is scanning, it is turning on power to each of these slots briefly, reading them, and then going on to the next one. And we can clearly visualize how power is being applied to this. And that was also the principle used because there were some light-up figures. Now, the light-up figures came out. This particular kiosk runs version 2.0, and the light-up figures didn't come out till version 3.0, but let me show you what the light-up figures look like. So here's Yoda, who was part of the Star Wars pack that this doesn't recognize, so you're not missing a video, it's just ignoring him. But you can see his laser pulsing, and it's pulsing rather than blinking like this one did. And the reason for that is that there's more circuitry in there to smooth and store the power, and the game that supported version 3.0 also via software kept the scanning, recognized if there was a light up character anywhere on there, and it would consequently lengthen the scanning time or the time that it scanned a particular slot, so that in the game basically you didn't see any pulsing on it, but the thing would come on permanently. And there is a living proof of how RFID tags get powered. Now, getting any deeper into the communication is beyond the scope of this video, and if I see people expressing interest in it, I might cook up something for a future video. But this basically completes our tour of RFID as used in video games. But that's not all. I also got this, which was the Skylanders store display kiosk for their version or their edition of the Trap Team toys. So let's power this guy on. I got him from the same place, from the same living room, for the same price. Didn't need a whole lot of work. I did poke through it a little bit. This one isn't Android based, but rather it's running an embedded version of POSIX. Then it runs a Lua interpreter on top of that, and all of the game code is written in Lua script, and it pretty much does the same thing as the Disney one does. It just checks the SKUs or the toy IDs and plays a video. If it has the video relative to that, it plays that video. So, same operation. I put this guy on there, who's Funny Bone, and it'll play a video for us of what Funny Bone does, and make us want to run to the cash register and buy him, I guess. The difference here is that it's a bit more responsive than the Disney one, because when you remove the toy, it will immediately go back to the main loop on this. Now, the equivalent, Skylanders has their own reader, or portal as they call it, and it looks like this. And of course I had to tear it apart, and it was very interesting because it's basically a single slot reader, and it has an antenna loop going around the perimeter of the case. So it only has a single slot. So what I was thinking was, well, if it only has a single slot, that means it is not scanning. And if I put Yoda on there, I should get Yoda with a non-pulsing lightsaber, where the lightsaber is basically on all the time. So let's give that a try. So here's Yoda, and yes, he does light up, and he lights up consistently. Let's see if I can make that a little bit more clear, but there you go. You see his lightsaber's on, it's not pulsing, and that's because the field generated in the antenna is basically on all of the time, and it's just continuously harvesting energy on it with no interruptions. So that's what it looks like. Now, one way I think you can turn off that field is if you press one of the buttons on there, and it will stop. It'll turn the antenna field off, I think. No, it doesn't. I guess the antenna field stays on. Even though maybe I'm imagining this, but it looks like it got a little bit dimmer. But there you go. Oh, this guy's annoying. Let me see if I can turn the volume down on this. Come on. Wrong button. So there you have it. Well, I hope this was a good introduction to RFID. We only scratched the surface. We only really looked at the energy harvesting and of course how it's used with games, but you can basically use RFID to identify pretty much anything. I mean, people even use it for security on their computers. They stick one of those tags maybe on their bare skin, and the minute they get close to their desk, the computer unlocks automatically. I hear there's some real crazies out there who's had these tags embedded in their wrists or in their hands, and basically walk around with those and enable or gain access to everything in their home or business by waving their hand in front of things, which is probably really impressive the first time you see it, but having one of those embedded in you, well, whatever. Anyway, thanks for watching this, and make sure your voice is heard and you click the like button. And of course, if you haven't yet, subscribe. And make sure to leave me a comment. Again, I read every single comment. I may not answer every single one because I don't have the time, or a comment seems like it doesn't need an answer, but I still read them, and I really enjoy it when you leave some. So thanks for watching again, and we'll see you soon.